Welcome to another set of video notes. We're going to look at 2-4 today, which is how to write the equations of lines. Now, one thing you've got to keep in mind, or keep track of, you will need to find a slope and a y-intercept. And hopefully, you're already thinking y equals mx plus b. Okay? Well, I might ask you to tell me what the equation of the line is and just give you the slope and y-intercept. So let's see, I told you what m is, I told you what b is. All you're going to have to do is plug in the values. So here we go. Y equals, what's the m? 3 goes with the x. What's the b? Plus 1. You're done. That's as easy as it is. You are needing slope and y-intercept. We have them. We plug them in. Let's go on to the next one. We are given slope. We are given y-intercept. All we have to do is plug them in. Do I plug anything in for y? Nope. I wasn't given y. Do I plug anything in for m? Yes, sirree. Negative 1/2. Do I plug anything in for x? Nope. But I was given b, so minus 3, and you're done. Some of you might say, well, could I write plus and negative 3? I would rather you not. Remember, we're trying to get out of that double sign habit. It can cause problems later on. Easiest problems. Hopefully you're thinking pretty easy too, and you're ready to move on. Okay, the next type of example or problem you might be expected to do is you will be given a slope and a point. So, we're going to write out the steps for this, but before I do that, I want to give you the point-slope form. So, point-slope form. And what that says is y minus y1 equals m parenthesis x minus x1. Okay, so far you've seen slope-intercept form, you've seen standard form, and this is our last one. Now some of you are going to want to fight me on this. You're going to say, oh, let me do the other way. No, I think we're going to do this way now that we're in Algebra 2. Okay, so first step, you are given slope. So plug slope in, and you're also going to plug in the coordinates of the point, 2, x1, y1. Okay? So, let's try that over here. Rewrite the equation y minus y1 equals m parenthesis x minus x1. Okay? What does this 8 take the place of? Oh yeah, x1. And what does the negative 1 take the place of? y1. And I said m, so you're good. So here we go. Do we plug anything in for y? Nope. Minus a negative 1 is like plus, remember? And then what do we plug in for m? Negative 1/2. What do we plug in for x? Nothing. But what do we plug in for x1? 8. Why is there a negative there? I don't see a negative there. Oh, that's right. The formula has a minus in it. Okay? So here we go. What does it mean to have a number outside of a parenthesis? Distribute? Very good. So let's move on. We've got y plus 1 equals negative 1/2 x. Now, tricky one. What is negative 1/2 times negative 8? Plus 4? Very good. Plus 4. What else do we have to do to get it into slope-intercept form? Just subtract the 1. Y is now by itself. Why am I combining the 4 and the negative 1? Oh yeah, that's right. They're like terms. And so that's plus 3. Okay? Easy enough? Just kind of plug and chug? All right, well, let's go through this one. So we plug the slope in and plug in the point. What did we do next? Let's remind ourselves. Oh yeah, we distributed. And then we worked to get y by itself. Okay, good. All right, well, let's go through. We've got 2 more examples that go along with this. We say, well, it goes through 4 and negative 2, and it's going to be parallel to a specific line. And so this is the other extra thing, and I'm going to grab a black marker. The equation of that line that it's parallel to is y equals 3x plus 6, and it's perpendicular to y equals, yeah, well then we want the perpendicular. We'll leave it like that, okay? All right, so if it's parallel to y equals 3x plus 6, what's going to be true about their slopes? Oh, they're the same? So what's the slope going to be? Oh, m equals 3? Hey, you already have that, don't you? Okay, so let's start plugging in. We want to plug the slope in and plug in the point. So, I don't think we need a parenthesis there. Y, and which one of these numbers, 4, -2, or 3, is going to be used? The y, oh yeah, that's -2. So y minus the -2, oh yeah, it's plus. Now, which one of these goes in for the slope? The m or the 3? Do we plug anything in for just plain x? Nope. But we do plug in the x1 coordinate, which is 4. So we've got x minus 4. Okay? Well, what did we say to do? We've plugged it in, distribute. So we've got y plus 2. You get 3x minus 12. What do you get y by itself? Subtract and you get y equals 3x minus 14. Okay? So that's the line that's parallel to this line that goes to that point. Okay? Now we want to find the slope or the line, equation of the line that's perpendicular to this one and goes to this point. What do you know about the slopes of perpendicular lines? Are they the same? You're right. The slope is going to be this one, only reciprocal, so that's 1/3. And does it stay positive, become negative? What? Becomes negative. Good. Now, let's start plugging things in. We're going to plug in the -2 for y1. So y minus the -2 is plus 2. The slope is -1/3. And then we've got, do we plug in for x? No, you were good. Right. Don't plug in for this plain one. Plug in for the x1. So minus 4. Now, what happens? Well, we distribute. -1/3 times x is just -1/3 x. What is a negative times a negative? Oh yeah, positive. And think of this as 4 over 1, so 1 times 4, 4. And 3 times 1 is 3. Okay? What do we have left to do? Well, we've got to get rid of the -2. And this might be where you go, oh, I want to do fractions. They won't be too bad, I promise. This is 4/3. We can think of -2 as -6/3. And when we add them, you're right. You get -2/3. Okay? See how we're doing this? Lots of plugging in and evaluating, which luckily you've gotten really good at. Remember, the whole idea here is we're given slope and a point. Sometimes we might have to do some thinking to come up with the slope. Think about what's true about parallel lines, or what's true about the slope of perpendicular lines. Okay? Now, we've got one more main idea to do, and this is how to get the equation of the line only from 2 points. So we'll move on over to this one. Okay? And let's write down the steps. Well, what did I tell you before you always need? You always need slope. Oh! So I bet our first step is going to be find m. Or in other words, whatever the slope is. Hey, if you want to know the slope and you've got a point, don't you already know how to do that? Exactly. You are going to plug in m and one of the 2 points. It doesn't matter which one you do. And then guess what? We're back to the old problem. So that means distribute. And the last step I think said something like work to get y by itself. Now some of this, and I squished by itself together again. Sorry about that. Some of this you might want to go ahead and get on your study card, especially the steps, and then when we're in class I might give you some other hints. So, first thing that we have to do, we've got 2 points, we need to find the slope. So I'm going to label these x1, y1, x2, y2. Hopefully we can remember this formula for slope. We need to take y2 minus y1 over x2 minus x1. Let's see, what is y2? Negative 7 minus y1 minus 5 all over 4 minus a negative 2. Good. Everybody see how we've plugged them in? So negative 7 minus 5 is negative 12. 4 plus 2, and see how that gets confusing, but because it's minus a negative, that's like adding. 4 plus 2 is 6, so your slope is negative 2. You've got your slope, you've got a point. I think you know how to do this. You're going to take y minus y1 equals, sorry about that, m times x minus x1. Let's plug it in. Do we plug in for that first y? No. Do we plug in for the y1? Yep, and it's 5. Do we plug in for the m? Yes, it's negative 2. Do we plug in for the x? Nope. Do we plug in for the x1? Yes. Minus a negative 2, ooh, that's like adding 2. Okay, let's, what do we do next? If you check the steps that I'm blocking with my body, distribute. So we get negative 2x minus 4. We've got to work to get y by itself, so this time we're going to add 5. I wonder if any of you can realize why we're adding 5 this time instead of subtracting. Oh, because this was a negative to begin with? Very good. So you get negative 2x plus 1. Good. Now some of you might say, well, what if I didn't put them in like that? What if I called this x2 and y2, and I called this x1 and y1? Guess what? It doesn't matter. But let's try it just in case you don't believe me. This time we're going to have 5 minus a negative 7, and we're going to have negative 2 minus 4, and we get 12 divided by negative 6, which, oh, guess what? It's still negative 2. Now we can plug it back into y minus y1 equals m times x minus x1. So where's our y1? Well, here it is. We've got y minus a negative 7. Oh yeah, that's that tricky plus. M, we already found, was negative 2. We don't plug in for the plane x. Let's do x1. It's 4, so minus 4, because remember there's a minus in the equation. All right, and what do you do next? You distribute, and you get negative 2x plus 8. Good so far? And then, let's see, we got to get the y by itself, so subtract 7. Got to put it over there by its like term, and you get negative 2x plus 1. So either way, you get the same equation of the line, okay, because both of these points are on it. So it's fine. So that's pretty much what we're going to do. We will look at how to do a word problem when you come to class on Wednesday, and hopefully I'll be handing back an amazing quiz you did on 3-1 through 3-3. So, or 2-1 through 2-3. But that's it for today. Hope this helps and you're ready to work. Bye.